Imagine a building so massively huge that it reportedly has its own microclimate. Well, welcome back to The Explainer. Today, we're doing a real deep dive into the literal largest building in the world by volume. If you follow aviation manufacturing at all, you already know the Boeing Everett plant is undergoing some of the most significant physical and operational shifts in its nearly 6-decade history. So we're going to decode exactly how this massive space is structured and what its future actually looks like.
But hey, right off the bat, just a quick bit of housekeeping. This explainer serves as a very specific correction to some geographical and logistical misconceptions from a previous piece of content regarding Everett's layout and operations. We're here to set the record straight using the actual source data. You can find a direct link to the original content we're addressing down in the description.
Here is our roadmap for today. We're going to cover the Everett address enigma, how to actually navigate the megafactory, the CWC expansion, the brand new 737 North Line, wing transport logistics, and finally wrap up with the current production caps and delays. All right, Section 1, the Everett address enigma, and locating the main gate.
Okay, so let's start at the perimeter, tackling the whole widespread confusion about where this facility is actually located. It sounds literally foolproof, right? You just punch the address into your GPS. But at Everett, doing that might actually leave you locked out. There's a really stark contrast between the official paperwork and the reality on the ground. The legacy postal address from back in 1966 is 3003 West Casino Road. But if you navigate there today, it merely leads you to a highly secure south fence line with absolutely zero public through access. Why? Well, because the campus expanded so massively northward over the decades. To actually get inside, specifically to Building 488 for visitor badging, you have to exit the highway at Seaway Boulevard and turn onto 100th Street Southwest. It's literally a mile-long disconnect between the official digital address and the actual place you can walk through the door. Moving right along to Section 2, navigating the megafactory and decoding the grid. Once you actually make it inside the doors, you can't just say, hey, meet me down the hall, because, well, the hall is roughly the size of a small city. We're talking about a massive 98-acre footprint. To put that in perspective, you could fit 75 American football fields inside this thing. This sheer scale completely explains why standard navigation methods absolutely fail indoors. The factory itself isn't even thought of as one single room by the people who work there. It's a huge interconnected network of distinct zones. So since your smartphone map is completely useless in here, workers rely on a highly specific alphanumeric grid. Imagine trying to find your way around. You look up and painted 8 to 12 feet high on the concrete columns are these high-visibility yellow and red labels, and they have to be painted that high just to be seen over the massive aircraft parts and machinery. Administratively, this huge interior is segmented into dozens of sub-buildings using a 40-X numbering format. So for instance, if you're trying to navigate to the south side of the factory floor, you're actually moving through zones designated as 4021 through 4026. All right, Section 3. The CWC factory expansion and a footprint evolution. This footprint definitely hasn't stayed static since the 1960s. Prior to 2014, older office blocks and parking lots sat to the north of the main factory, but Boeing demolished those to construct the Composite Wing Center, or the CWC. That addition alone is a 1 million square foot facility, and this physical separation was absolutely vital. You see, producing a traditional metal wing generates a ton of metal particles and oily air. That environment absolutely cannot mix with the sterile, pristine conditions that are required to bake the carbon fiber composite wings of the new 770X. Which brings us to Section 4, the new 737 North Line and reclaiming space. This whole expansion we just talked about, combined with the retirement of legacy programs like the iconic 747, created a pretty huge spatial vacuum inside the main building. And that vacuum is now being filled by something genuinely unprecedented. For its entire 58-year history, Everett never built a narrow-body aircraft. But that's changing right now. The North Line is taking over the former 787 and 747 space, specifically over in Building 4026. What's super fascinating here is that this line will be exclusively dedicated to the 737 MAX 10 variant, which is the largest and most complex of the entire MAX family. But they aren't just flipping a switch and running at maximum speed. They're utilizing what's called LRIP, or low-rate initial production. It's a very deliberate, highly cautious slowdown. It basically allows the new teams, which are a mix of rent-and veterans and new hires, to warm up their muscles, ensure absolute quality control, and carefully demonstrate total FAA compliance before they ever get the green light for full-rate production. Okay, Section 5, Wing Transport Logistics, getting from Renton up to Everett. Now, you might be wondering, if they're building the 737 in Everett, what about the wings?
Well, building brand new wing tooling up in Everett would be incredibly redundant and risky, so wing assembly actually stays 30 miles south in Renton. But how do you actually move them? It requires exact precision. Fully assembled wings have to be loaded onto a specialized 737 wing transport tool. The logistical challenge here is just immense, particularly if they're utilizing the rail network, because that route is compounded by the Everett facility's incredibly steep 5.7% rail grade. Once the wings finally make it to Everett, a completely new facility layout and an overhead crane crew utilization plan takes over to safely unload them and integrate them into the 4026 building assembly line.
And finally, Section 6, production caps and delays, or basically the current reality on the ground.
38. That is the magic number right now. 38 is the absolute maximum number of 737 MAX aircraft that the FAA currently permits Boeing to produce per month across all of its lines combined. So despite all that massive physical expansion we've been discussing, the ultimate pace is currently dictated by this hard cap, which was put in place to ensure quality and safety standards are flawlessly maintained.
Boeing literally has to stabilize that rate of 38 perfectly at the Renton plant before they can even petition the FAA to allow the Everett North Line to fully accelerate. Now, looking ahead, the 767 program will officially cease deliveries at the end of 2027, which is going to free up even more of that massive factory floor. But despite this new space opening up, immediate momentum is pretty stalled. Certifications for both the flagship 777X and the 737 MAX 10 have been pushed out into 2026. For the MAX 10, this delay is specifically driven by some highly complex, unresolved engineering work on the engine anti-icing system, specifically to prevent thermal degradation of the engine inlet. They absolutely have to lock in that design fix before the FAA moves forward.
So as Boeing completely recalibrates this colossal 98-acre space, you really have to wonder, can this historic 1960s-era factory seamlessly adapt its legacy to survive today's unprecedented regulatory scrutiny? The transition from the Queen of the Skies to the MAX 10 isn't just a new assembly line. It's a profound test of Everett's entire future. If you enjoyed decoding the logistics of this mega factory with me, please give this explainer a like, share it with your colleagues, and make sure you subscribe to the channel. Thanks so much for learning with me today, and I'll see you in the next explainer.